So we are going to start electrolysis, and in the last class we have discussed redox. Okay, in the last class we have discussed redox. Okay, so what is electrolysis? What is electrolysis? Basically,
Decompose.
electrolysis means, yes, it's the breakdown of any compound. Okay, it's the breakdown of any compound by means of electrolysis. It's the breakdown of any compound by means of electrolysis. Okay, so we can also break down the compound by providing heat. We can also break down the compound by providing heat. But remember, for those compounds which are stronger, ultimately, then we have to provide them electricity, so they would be breaking down in an easier manner. Okay, they would be breaking down in an easier manner. Okay, so electrolysis is a process by which electric current is passed through a substance. Okay, through a substance. So as a result of this, the substance would be breaking down. Ultimately, electricity is a form of energy, and you are going to provide energy so that the compound is broken down. Okay, so like why we are going to break down a compound? Why we are going to break down a compound? Basically, there are multiple reasons. If you ask, so let's suppose I need chlorine gas. Let's suppose I need chlorine gas and I have sodium chloride. Okay, I need chlorine gas and I have sodium chloride. So what am I supposed to do? Basically, I would be providing energy to the sodium chloride. Then the sodium chloride would be breaking down into sodium and chlorine gas. Into sodium and chlorine gas. So this is the advantage of this electrolysis. Not only this, a lot of like the reasons that we have to do electrolysis. So we would be discussing it. But right now, electrolysis is the decomposition of ionic compound when in molten state or in aqueous state, or it's a solution by the passage of current. Sometimes you will see you have a molten compound. What is molten compound? Molten means the compound is melted at a higher temperature. Molten means what? The compound is melted at a higher temperature. Okay, this is called the molten electrolysis, the breakdown of any compound by using electricity. Okay, and sometimes you will see your compound is aqueous. Sometimes you will see your compound is aqueous. Aqueous means that the compound is soluble in water. You have dissolved the compound in water. Now the compound becomes a good conductor and you can break it down easily. So this is mandatory that the compound should be a good conductor of electricity. Otherwise, if the compound is a bad conductor, ultimately the compound is not going to conduct electricity. So you can say that the compound is not going to be broken down. So this is the primary thing, that the compound should be a good conductor. You know, when we were discussing ionic compounds, then I told you that ionic compounds are bad conductor of electricity in a solid state. If you remember, ionic compounds are a bad conductor of electricity in a solid state because ions are not free to move. To make it a good conductor, we have to do two things. Number one, you can convert it into a molten state. And you can convert into an aqueous state. Like you are supposed to dissolve ionic compound in water so that the ionic compound should be a good conductor of electricity. Then just start to provide electricity, and as a result of this, your compound would be breaking down. That's it. Okay. So, like what are the apparatus that is needed to start electrolysis? Okay, what are the apparatus that is needed to start up electrolysis? Number one, you need electrolytic cell. Then you need electrodes. Then you need electrolyte. Then you need power supply. Then you need wire. Then you need wire. These are the things that we would be like having when we would be doing electrolysis. So first of all, what is electrolytic cell? In simple words, I can say that this is a container. This is a simple container. This is what? This is a simple container or a beaker sometime or most of the time. It's a beaker in which we do experiment. We do what? Experiment. Let me show you something. Wait. If you can see this, yes. Basically, you can see the beaker in which we have water. Okay, you can see the beaker in which we have water, and we used electrodes. Then we have attached, connected a battery, a power source. Then we have started to provide electric current, and then you can see, then you can have observation as a result of this electrolysis. So I would be telling you multi-purposes of doing electrolysis, okay? But right now, you must know these all the terms. You must know these all the terms, okay? So first of all, electrolytic cell, in which we would be converting electrical energy into the chemical energy. Electrical energy into the chemical energy. Let's suppose this is sodium chloride. This is your chemical. Let's suppose this is your chemical, okay? This is your chemical, and you are going to provide energy. You are going to provide electrical energy, just like that. You are going to provide electrical energy. You are going to provide electrical energy. So you will see that your electrical energy is going to break down this chemical, just like that. That's why what I have written, that electrical energy is converted into the chemical energy. Electrical energy is converted into the chemical energy. So this is the purpose of doing electrolysis. This is the purpose of doing electrolysis, that we would be converting electrical energy into chemical energy. Okay. Then we have electrodes. So what are electrodes? Electrodes, you can say that these are the plates. These are the plates on which oxidation or reduction takes place. I would be explaining you in a detail. This is very interesting topic, trust me. So electrodes are nothing but it's a plate on which there is a transference of electron. Whether they are going to lose electron, whether they are going to gain electron, okay? And then we have electrolyte. Electrolyte is a solution which can conduct electricity. Again, it can be molten, it can be aqueous. It can be molten, it can be aqueous, but it should be a good conductor. Again, let's suppose You have taken a solution which is a bad conductor of electricity. So how can you expect that the compound would be breaking down? Ultimately, electricity is not going to be passed through the solution. So obviously your compound cannot be broken down. You cannot do electrolysis. So this is a mandatory to have such a solution which should be a good conductor of electricity, which should be a good conductor of electricity, okay, which should be a good conductor of electricity, right? Okay. uh okay, like acids, they are good conductor. The salts, they are good conductor, without like, except some salts. I would be telling you which salts are, you can say, bad conductor of electricity. Okay. uh H2SO4, that is sulfuric acid. Okay, this is sulfuric acid. This is also a good conductor of electricity. You can also do electrolysis for sulfuric acid. Copper sulfate is soluble in water. This is a good conductor of electricity. We would be doing electrolysis for copper sulfate. We would be breaking down copper sulfate. We would be breaking down HCl. We would be breaking down NaCl. We would be breaking down HNO3. We can also do electrolysis. So I want to tell you that when you have a soluble solution, soluble salt, or a soluble substance, ultimately, if this is a good conductor of electricity, so feel free to pass electricity through the solution. So the compound would be breaking it down. Okay, so the compound would be breaking down, and then you can say that you have electrolyzed the solution. You have electrolyzed the solution. Okay, so these are the primary things that you need to know. Okay. uh, you can say that, uh, let me explain electrodes. Let me explain electrodes. But before explaining electrodes, let me tell you, these are the apparatus that we had when we were doing electrolysis. Now it's time to assemble all. Now it's time to assemble all. How can we assemble? How can we assemble them in this manner? First of all, this is your electrolytic cell. This is your battery. These are the wires. This is an electrode. This is your electrolyte. So basically, in this way, you can assemble electrolyte, electrodes, battery, a wire, and electrolytic cell. Okay? And then let's suppose, uh, let's suppose, see this. Let's suppose you have copper. Let's suppose you have what? Let's suppose you have graphite. You have graphite. Hopefully, you all people know that graphite is made of carbon. Graphite is made of carbon. And graphite is a good conductor of electricity. And graphite is a good conductor of electricity. Okay? This is the reason we can take graphite as an electrode. This is a good conductor. And also this is inert. And also this is inert. Huria, can you tell me why graphite is a good conductor of electricity? Yes, Huria? Can you tell me? Yes, Huria? Can you tell me, please, why graphite is a good conductor of
Sir,
electricity?
it's a good conductor of electricity because of its structure, like it has electrons to move freely.
Exactly. You can say that it has free electrons. You can say that it has free electrons. Okay. You can say that it has free electrons. This is the reason it's a good conductor of electricity. Okay. This is the reason it's a good conductor of electricity. Remember. Okay. So now I want to tell you that, I want to tell you that, let's suppose I have two pieces of graphite. Let's suppose I have two pieces of graphite. This is the first piece. This is the first piece. Okay. Same as I have the second piece of graphite. I need your concentration, please. I need your concentration. Everything would be clear. Everything would be clear. 110%. I have a battery. Then, oh my God. Oh my God. Okay, yes. Then I have a battery. This is my battery. This is my battery. Oh, this is my battery. Okay, power source. You all know that the battery has two poles, positive pole and the negative pole, like the positive terminal and the negative terminal. Okay, the positive terminal and the negative terminal. Okay, let's suppose I have attached graphite. I have attached graphite to the positive terminal of the battery. And then I have attached graphite to the negative terminal of the battery. To the negative terminal of the battery. Ultimately, you can say that, sir, it has a negative charge. Then I would ask why. Then I would ask why. Then you can say that, sir, you have attached this part to the negative terminal of the battery. And then, sir, it has a positive charge. I would say why. Then you would say that because, sir, you have attached this plate to the positive terminal of the battery. And it's common. It's very common. It's not a rocket science. Ultimately, if you are going to attach anything to the positive terminal of the battery, so that thing would become positive. Let's suppose this is a magnet. Let's suppose this is a magnet. Okay. Let's suppose this is a magnet and you have attached a nail to this magnet. Let's suppose you have attached a nail to this magnet. Ultimately, this nail becomes magnet. Then you can attach multiple nails to this nail. Ultimately, because you have induced magnetism. You have induced magnetism. You have induced magnetism. What it's happening over here, when you are going to attach a substance to the positive terminal of the battery, so that substance would be having positive charge. So that substance would be having a positive charge. And if you are going to attach the substance to the negative terminal of the battery, then you will see that the substance would be having a negative charge. Okay, then I want to say that, let's suppose this is the species I have. This is the species I have. It has a positive charge. It has a positive charge. Now my question is, where the species would go? You will say, sir, this species would go towards this. Then again my question. Then what would happen? You will say that, sir, this species would gain one electron and then it would become zero. It would become neutral. It has a zero charge right now. Then I would ask, can you tell me the name of the process? You will say, sir, this is a reduction. Then if I ask, what is reduction? You will say, sir, gain of electron. Then I will say that this point is very important. Okay, you're supposed to note it down, that on negative electrode, professionally, technically, this is called cathode. Red cat. What does it mean? Reduction at cathode. Always remember, reduction occurs at cathode. Remember, reduction occurs at cathode. Always this is fixed. Remember, okay? Reduction occurs at cathode. Whenever I ask, what is the name of the process that occurs at cathode? You will say, okay, so always remember, when I would be asking cathode, then you would say that reduction is occurring at cathode. Reduction is occurring at cathode. Always remember, this is fixed. This is fixed. And then let me tell you. Then right now I have this ion. Right now I have this ion. This is a negative ion. Then I ask where the ion would move. You would say, sir, towards the positive. Opposite charges attract each other. Then I would say, what would happen? Then you will say that, sir, when this negative ion will go towards anode, this is called anode. This is called anode. When you have attached the plate to the positive terminal of the battery, it would become anode. It would become anode. So when any negative ion will move towards anode, so remember, it would be gaining electron. Just like that. It would be losing electron, because any negative ion is electron rich. Why it has a negative charge? This is electron rich. It has to lose electron. When it would lose electron, again it would become zero. Then I would ask, what's happening? You will say, sir, it's a loss of electron. So what is the loss of electron? You will say oxidation. Loss of electron is oxidation. So remember, always oxidation occurs at anode. So this is anox and red cat. Anode oxidation occurs at anode and reduction occurs at cathode. Oxidation occurs at anode and reduction occurs at cathode. This is very important point. Otherwise, you will not be able to understand electrolysis. These are the basic terms that you need to know before going to start electrolysis. Okay, before going to start electrolysis, right? Let me do some practice with you. Okay, so right, so far we have decided. So far, summary. So far we have decided. Reduction occurs at cathode.
Cathode.
And at anode. So far we did this. And then ultimately I can say that reduction is a gain of electron. Oxidation is loss of electron. Okay. Yes. Okay. Positive ion travel towards negative electrode, which is called cathode. Then will gain electron to become neutral. To become what? Neutral. These are the golden points. Trust me, these are the golden points. And then when you have a negative ion travel towards positive electrode, that is called anode, then will lose electron to become neutral.
So what do you mean by neutral?
I would be telling you each and everything. Just give me 1 minute. Let's do some practice. Okay, then, okay. At cathode, at anode. Okay, at cathode, at anode. Okay, we have these ions. We have these ions, right? We have these ions. Okay, 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 okay. So then I would ask, let's ask from Maheen. Maheen, can you tell me where this ion would go? Towards cathode or towards anode? Can you tell me, please?
Towards the cathode.
Why? Why?
Sir, because cathode is negatively charged, so the positive ion will go towards the negatively charged electrode.
Excellent. Excellent. Cathode is negative. So that's why this ion would go towards cathode. No, 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 just like that. And then it would be gaining one electron. Now the Amaya asks, sir, why? How can you say that it has to gain one electron? Sir, how can you say that it has to gain one electron? I would say that this is in group 1 and it has a +1 charge. 1 plus means it needs 1 electron. 2 plus means it needs 2 electrons. 3 plus means it needs 3 electrons. Remember, this is very important. 1 plus means it needs 1 electron. 2 plus means it needs 2 electrons. 3 plus means it needs 3 electrons. So this is the reason Na plus would be gaining 1 electron, and then there is no charge on sodium. There is no charge on sodium. There is no charge on sodium. Let me tell you in detail, in a deep. Let's, how many electrons it has? You will say, sir, 10 electrons. How many protons it has? You will say, sir, 11 protons. What is the overall charge? You will say, sir, +1. Right now it has gained 1 electron. How many electrons it has? You will say 11 electrons. How many protons it has? You will say, sir, 11 protons. There is no charge because they have cancelled each other. This is the reason I was saying that to become neutral. To become neutral. Yes. Can you yes. Are you getting my point? Yes. Someone is asking something regarding neutral. Are you getting my point? Yes? Yes or no? Or should I explain again?
Sir, can you explain again?
Okay. So I mean to say that I have written when positive ion travel towards negative electrode. I mean to say that when positive ion will travel towards this negative electrode, ultimately it would gain 1 electron to become neutral. This is the reason. Sodium positive has gained 1 electron. Ultimately, right now it has 11 electrons and 11 protons. It's mean that +11 and -11, they cancelled each other. As a result, there is no charge. When there is no charge on atom, I can say that this is neutral. Neutral means no charge. Neutral means no charge. But before, when it had, in this form, it had a positive charge because it was seeking 1 electron. It was seeking 1 electron. And when it has gained 1 electron, so right now it has no charge. Are you getting my point? Yes or no? Okay.
Yes.
Okay. Let's suppose then we have Mg2 plus. Then we have Mg2 plus. Abdul Wase. Can you tell me where this Mg2 plus will go? Towards cathode or towards anode? This and this. Yes. Sorry. Sorry. Your voice is not clear.
Sir, at cathode.
Cathode. Exactly. So how many electrons it would be gaining? Ayat Zubair, can you tell me, Ayat Zubair, how many electrons it would be gaining? Yes, Ayat and Adan both. Can you tell me, please, how many electrons it would be gaining? Adan, can you tell me? Adan?
Yes, sir.
How many electrons it would be gaining? This is Mg2 plus.
Sir, 2.
Exactly. It would be gaining 2 electrons. Now this is neutral. There is no charge. I'm not supposed to write 0. I'm saying that this is 0. This is common sense, neutral. Okay, okay. Now I have Al3 plus. As you know that this has a positive charge, it would be going towards cathode, would be gaining 3 electrons. And after gaining 3 electrons, there would be no charge on aluminum. Amaya, can you understand? Can you understand it? Yes. Mohaimin,
Yes, sir.
Iman, Umar, मदार का तो ओके ओके की रिपोर्ट है यार मदार का आर्यन हाउ आर यू आर्यन लॉन्ग टाइम नो सी आर्यन
Yeah, sir.
ओके यस मदार का
Uh, sir, I just have like exam, so that's why I don't speak a lot.
सॉरी
Kisko? I have like my O-level exam, so that's why I don't speak much.
ओ भाई ओके ओके भाई ओके यू आर सो मच बिजी ओके अल्लाह कामयाब करे बेटा आपको ओके तो